page 18 of your notes. We're getting there towards the end. We have this lesson and then our lesson that we have tomorrow, and then we'll be at the end of our packet. You will have a quiz on Thursday over surface area and volume to kind of get like a temperature check of where y'all are at before we take our test next Tuesday. So it'll let me know what we need to review on Monday so that you're ready and we have better test scores this time than we did with the circle test. Yeah? Yeah. We need better scores than we had on the circle test. Alright, so these right here are really, it's just word problems, and you just have to pay attention to, is it asking for surface area or is it asking for volume? So remember, volume is asking for what? What are some key things that volume is? So if it's volume, it's going to have things like cubic, or how much can it contain or hold. It's on the inside, like, space, right? And then if we're talking about surface area, we're talking about like wrapping the shape, right? We're talking about the sides. Not slides, sides. If we're lining something, like y'all ever put tinfoil in a pan before? And you put it all around so that the stuff doesn't stick or that it cooks good or something like that? When you're lining a cooking sheet or a pan, you're doing the surface area of the pan. Okay? That's surface area. Now when you put the stuff in the pan and you're packing it in there, that's volume. So like if you've ever baked a cake before and sometimes you want to line the cake pan with, like, some people use parchment paper, some people use like a spray or flour or something first, and you line the walls with it, that's surface area. But when you pour in the cake batter and fill it up, that's volume. Okay, so there's the difference between the two. Alright, so we're only talking about cylinders today, and then tomorrow we'll throw in all the other shapes. Yay, right? Because y'all love triangles. We know you do. Alright, so we've got some youth sports club is holding their yearly tri-county tournament. The club is selling fruit cups in 2 different sizes. We want to fill in the missing information in the table after completing the 2 parts. So we have a regular size fruit cup, and we have a large size fruit cup. You notice that both of them were given the diameter, okay? But even if we're talking about volume or surface area, what do we use? What do we need?
The base and the base.
We need the base and the height, and the area of the base requires area, and area requires the formula, which is pi r squared. Do we have our r's? What does this 2.8 represent? This is the diameter, so we need the radius. How do we find the radius?
Divided by 2.
So what is 2.8 divided by 2?
1.4.
Alright, so our radius for our regular is 1.4. And down here at the large, our diameter is currently 3. So what would our radius be? What's half of 3?
Is 1.5.
1.5. Okay? That way we already have that taken care of. We're still going to use our highlighters, so I hope you haven't put your highlighters up. We're still going to be highlighting what the question is asking. So it says, find the volume of the large fruit cup to the nearest hundredth. Use the given diameter to find the radius. Use 3.14. So what is the question asking us to find? It's pretty straightforward. Find the volume of the large fruit cup. Do we have any special instructions here? Any special instructions on how they want the answer or what to do? Use 3.14. And what about rounding to the nearest hundredth? So if we're talking about volume, we're going to use the volume formula, which is, you should know, y'all all did really well on that. Volume is base times height. And that's not just base, it's the area of the base. So area of a circle, you've already told me, is pi r squared. Well, we found the radius for the large. What was the radius for the large cup that we found that you're supposed to write down? Alright, so we substitute radius with 1.5 squared. They told us to use 3.14 for pi, which gives me alright, and what was our height? 7. And what do we do with those two numbers? Multiply them. Ta-da! And we get that the volume of the large is going back to our special instructions, though, they want it to the nearest hundredth. Now, I should have counted some of y'all's is wrong on your homework quiz because it told you to round special wise and you didn't. It said round to the nearest cubic meter, cubic feet, meaning the whole number, and y'all didn't round to the whole number. Y'all left it as a decimal. Just pay attention to that. So the hundredths place, we've got tenths, hundredths. 5 looks at the 5, and the 5 tells the other 5 to do what? Go up. So 49.46 inches cubed. There's our answer. Alright, we could fill that into our chart up here. So what was the radius of the large? What was the radius? Was 1.5, right? And the volume was 49.46. Alright. Part B, find the volume of the regular fruit cup to the nearest hundredth. Substitute the given values and simplify. Use 3.14 for pi. What is it looking for? The volume. Find the volume of the regular fruit cup. Any special instructions? Use 3.14 and nearest hundredth. So y'all do that. Find the volume of the regular size fruit cup. What did you get as your height so far?
6.
Okay. What did you get as your area of the base?
6.2.
If you round, it was 6.1544 is what I got,
Yes.
right? But you're going to round to the nearest hundredth. You round at the end, okay? Don't round as you go, because if you keep rounding, you're getting further and further away from the answer. So save it and round to the end, especially since your calculator saves the number anyways. Just scroll up and hit that, you know how you can click it and put it into the problem. That's what I would do. So what do we do with these two now? Multiply them, and so we get volume equals, you should have got 36.9264 but we have to round what digits in the hundredths place.
Yeah.
Tenths, hundredths. 2 looks at the 6. 6 tells the 2
Go up.
go up. So you should have got a volume of 36 and 93 hundredths inches cubed. Ta-da. Was that terrible? Not really. Okay. Turn it over. This one's fun. I got a prop to help us out with. This one. Alright, a contractor. Do y'all know what a contractor is? A contractor builds houses. That's what a contractor does. Okay, contractor just means, well, contractor can be several different things. Basically, they're in charge of a job site. They're either in charge of building a house. If any of your people work on the base, some people who would work on the base, they're contractors and they're in charge of a project that's taking place on base. All kinds of different things like that. Basically, they're in charge, but this contractor is in charge of building a house. Is using foam pipe insulation and wants to know the total exterior. What does exterior mean? Exterior. So they want to know the outside surface area of each 6-foot section of insulation. The outside diameter of the foam is 1.75. The inside diameter is 0.75 inches. What are they wanting to find here? The total exterior surface area of each 6-foot section of insulation. Is there any important information in here? The outside diameter is this, and the inside diameter is this. And if you pay attention, they're 6-foot long pieces. So it's kind of y'all know what it's talking about when it says foam insulation that goes over pipes. Okay, it's kind of like a pool noodle, and they slide, but it's just thicker, and they slide like pipes through it to keep it from busting. I don't know if y'all have ever had your pipes bust or freeze over when it got really, really cold, but this helps prevent that from happening. So it's like a pool noodle. Y'all can use a pool noodle though, right? I know what a pool noodle is.
Yeah,
Okay.
I feel more.
It's essentially a pool noodle. But what they're wanting is the outside of the pool noodle, okay, including these. But what's going on here? It's got a hole, right? Like it's got a gap right here, right? So we have to take this part out because it's not completely covered with foam on this side, is it? No, so we're going to have to take this section out. And anytime we take a section out, what are we doing with it? We're subtracting. Yeah, so it's still going to be a cylinder. It's still the shape of a cylinder, right? A really long cylinder. It's still a cylinder, right? It's not quite 6 foot though, because I'm 5'4" and it only comes to my shoulder. So this is more like 4 foot. Okay, so it basically looks like a pool noodle. So they're going to walk us through how to solve this surface area. So the first part says find the surface area of the exterior of the insulation, excluding the ends. What does exclude mean?
Leave out.
Leave out, not included. Okay, that's why I put it on our lovely word wall. I also have exterior. Y'all like my outside picture? He's playing outside. And then I have my interior picture where he's playing inside. You like my little couch and coffee table and 1950s TV with the little antennas.
I can't see your exterior when you use mattress with your J-Max cup and your yellow light.
Listen, here's my exterior. See the little boy playing outside?
It's Jesus.
Okay.
No, that's an apple.
That's Jesus.
He's
Flower.
playing on luscious grass.
That's
Okay.
water.
So, anyways, exterior, outside, interior, inside. So we want to find the exterior excluding or leaving out the ends. So we just want to find the surface area of this part right here. Okay? Not including the bases. So what is surface area? All faces but the faces called. What is it when we just find this part, like the label part, and not the base? Lateral faces, or the lateral surface area. Alright, so we're going to find the lateral surface area, but here's some special instructions here. Leave your answer in terms of pi, and then round your final answer to the nearest hundredth. So we are finding surface area of the exterior insulation excluding the bases, which is just saying that we are finding the lateral surface area. How do I find lateral surface area? Yeah, just the perimeter times the height. We're not including the bases right now. So what is the outer diameter? When it says outer diameter, it means from here to here. Okay? The big one. It says, what is the outer diameter?
Hey, I'm only 0.25 inches off.
You're 1.75 inches. Well, if we need the P, the perimeter, which is the outside of the circle, what do we call the outside of the circle? Circumference. So that's why we're looking for the circumference. What circumference formula are we going to use if we have a diameter?
Pi.
Circumference equals pi times d. But because we're leaving it in terms of pi, we're not going to replace pi with 3.14. We're just going to leave it. So pi times 1.75 gives me 1.75 pi. Our diameter is measured in what? Look what inches. Okay? The length of our cylinder, or the height, so this is my P, this is my height. The length, how long do they say it was? The real thing, not this one, but the real thing. 6 foot. But because it's 6 feet, because our diameter is inches, we also need our length in inches. So how many inches are in a foot? 12. Be confident, you know this. There's 12 inches in a foot, and we have 6 of them. So how are we going to figure out how many inches? 6 times 12, using your multiplication facts, which is 72. So now we can find the lateral surface area. We're going to take our P and our H and multiply them together. So 1.75 pi times 72. So what is 1.75 times 72? Leaving the pi out. What?
126.
All right. That's our that's how much this part covers. Okay? Inches. Part B says find the surface area of the ends. The ends are like our bases, right? So now we're going to find the surface area of this. Okay, so we want to also leave our answer in terms of pi. Leave your answer in terms of pi. Round your answer to the nearest hundredth. So we've got a big circle basically, right? And we've got a little circle. We need to take the little circle out to figure out what's just this part right here. Okay? So what's the outer diameter is, we already have said, is 1.75. What would the radius, because we're finding because remember when we're talking about the base, we're finding the area of the base, right? And when I have the area, I need the radius, not the diameter. So we have to take 1.75, divide it by 2.
0.87.
So we're going to find the surface area, or just the area of this big circle. Okay, so that's where it comes in, and we're going to do, but because we have 2 of them, we have to multiply it by 2. That's why there's a 2 here. We're leaving it in terms of pi, so we're not going to do 3.14. And we're going to do r squared. So 0.875 squared, which leaves me with,
You can't see.
oh, my bad.
You stop sharing thing.
There it goes. Sorry. So there's 2 bases, 2 b's, right? And b represents area, and area is pi r squared. Well, we're leaving the pi. Our radius is 0.875 squared. So if we put that in the calculator, 2, leave out the pi symbol because we're going to drop it back behind our answer, times 0.875 squared, we get 1.53. Sorry.
I don't want 0.5.
You did.
I think I left that one.
Let me try it. Alright, 2 times 0.875 squared. 1.53125. But because it said round your answer to the nearest hundredth, it's 1.53 pi. Okay, so that's the big circle. Now we need to find the area of the little circle. And then we'll have to subtract it, right? So we have to do the same process. What would be the radius of the if we have an inside diameter of 0.75, what would the radius be? Okay, so we can put that into our formula. Let me come up here so you can see it. 0.375 squared. So what is 2 times 0.375 squared? Because we're leaving pi in the answer. You have calculators. Round it to the nearest hundredth, it would be 0.28 pi. So now we're going to subtract the 2. So we've got 1.53, the bigger one, pi, minus 0.28 pi, which gives me, so subtract those two numbers. So now we can take this part and add in our bases to get our total complete surface area. So we're going to take 126 pi plus our 1.25 pi, which is going to give me 0.25, yeah. And if we wanted to use 3.14, we would just take our 127.25 times 3.14, which gives me
0.56.
and round it to the nearest hundredth, which would be that's a lot. You probably won't have one on your test like that. Okay. You definitely won't have one like that on your homework tonight. Okay. Alright, this one's for my tennis players. Okay. Those of you who don't play tennis, do you know what tennis balls come in?
It smells amazing.
That little cylinder can that when you pop it like you pop a can and it okay. Alright, so we've got a tennis ball container here, and and you typically get about 4 tennis balls in a container, right? No? 3? I don't know. Maybe this is the off-brand. I don't know. They say we're going to put 4 tennis balls in there. Okay, that's what they say. I don't know. I don't know. Maybe they're not the professional brand. We're trying to see, it says Holly has an empty cylindrical container. She places 4 tennis balls in each with a volume of 9.2 cubic inches inside the container. What is the approximate volume of air remaining inside the container? So that tennis ball is taking up space, right? Every time we put a tennis ball in there, it's taking up space. We want to know how much space is left in the container, because it might need so much air so that it can breathe so it doesn't explode on you, right? So, what is the question asking for us? What could we highlight as what the question is asking for us to find?
What is the approximate volume
Of air remaining, right? What's some key information that we know? All right, there's a volume of 9.2 inches, each of them. What else is important? There's 4 of them. And then it's cylindrical, and we have these measurements down here, right? We have a height of 10.5, and we have a radius of 1.5. So this is my radius, this is my height. So part A says, find the volume of the cylindrical container to the nearest hundredth. Use 3.14 for pi. So what are we finding here? Volume. Any special instructions? Use 3.14 pi, and I heard round to the nearest hundredth. So find the volume of the container. That's what volume of the container. So let's find that real quick. Volume B times height. We already know the height. The height is 10.5. So we need to find the area of the lid or the base. So we've got 3.14 times the radius squared, which gives me,
7.065.
alright, so we're going to take that, thank you, and multiply those two numbers together. And your tennis ball container is what, Demiria? 0.182. Okay, and you round it to the nearest hundredth. What digit's in the hundredths place? 8, so the 8 looks to the 2. It stays the same. So 174.18 inches. So that's how much the container can hold. We need to know, well, how much space is getting taken up by the tennis balls, right? How many tennis balls do you have? 4. And what is their volume each? 9.2. So how are we going to figure out the total amount of volume they take up? How much space? So let's see how much space they take up. So 4 tennis balls take up, 4 times 9.2 is So they take up 36.8 inches cubed. So how are we going to figure out what's left?
Subtract that by,
Yeah, you take the total minus the part, right? To see what's left. So our total was 74.18 minus the 36.8. So how much air is left inside the container? 74, try that again. 74.18 minus 36.8. That one's more realistic of what you might have to do.
What'd you put on the bottom, total part, and what was over?
Total minus the part equals how much is left over. Okay, you're not going to do the on your own questions. Your homework comes from the homework packet. Once again, there won't be a pair assessment. There'll just be an answer key on Google Classroom for you to look over. Make sure you're actually doing the work because you'll have another homework quiz tomorrow. You got to pay attention to volume or surface area.